Good afternoon, dear students. Welcome to this session of EduSite program on Basics of Electrical and Electronics Engineering. Dear students, in the last class, I have explained you about the concept of resistance and the Ohm's law, which gives us the relationship between current, voltage as well as resistance. Okay. So, let us recollect all those concepts at the beginning. So, resistance is nothing but the opposition offered to the movement of free electrons in the material. It is expressed in ohms, and Ohm's law gives us the relationship between current, voltage as well as resistance. It states that the current flowing in the material is directly proportional to voltage applied and inversely proportional to resistance between the ends of the conductor. Okay. So, with this background, let us start today's session. The contents are series connection of resistances, parallel connection of resistances, series parallel connection of resistances, and numerical examples on Ohm's law and numerical examples for series and parallel connection of resistances. So, this circuit shows the series connection of resistances, and I have already explained you about the series connection of resistances. So, in the series connection, the effective resistance, this circuit also shows the series connection of resistances, and the effective resistance in the series connection is given by the equation R is equal to R1 plus R2 plus R3 if there are 3 resistances. That is, the characteristics of series circuits are: in a series circuit, the current through each resistance is same. The total voltage applied across the circuit is equal to the sum of all the individual voltage drops. The effective resistance is equal to the sum of all the individual resistances connected in series, and the effective resistance in a circuit consisting of n number of resistance is given by the equation R is equal to R1 plus R2 plus R3 plus R4 plus up to Rn. So, it is nothing but the algebraic sum of all the resistances which are connected in series. Now, let us look into parallel connection of resistances. So, this is the circuit which shows the connection of resistances in parallel. What do you mean by parallel connection of resistance? This circuit shows the parallel connection. In parallel connection of resistances, all the common points, that is the starting point of all the 3 resistances, they are connected to a common point, that is to the positive terminal of the supply voltage. Okay. Similarly, the finishing ends of the 3 resistances, these are the 3 resistances R1, R2 and R3. The finishing end of all the resistances are connected to the other end, that is the negative terminal of the supply. Okay. So, the resistances which are connected in parallel, they are connected between 2 common points. So, this type of configuration is known as parallel connection of resistances, and the voltage applied across the circuit is V, and I is the total current which is flowing in the circuit. Okay. And observe the currents in this case. Since there are 3 resistances in the circuit, the current I which is flowing in the circuit, it is splitting into 3 branch currents. Okay. I1 is the current which is flowing through resistance R1, I2 is the current which is flowing through resistance R2, similarly I3 is the current which is flowing through resistance R3, and the total current I is given by the sum of all 3 currents, and these currents are known as branch currents. Okay. So, with this background, let us try to find out what will be the effective resistance or total resistance in the circuit. I is the total current, I1, I2, I3 are the branch currents, R1, R2, R3 are the resistances, and V is the total voltage applied between the ends of the resistance connection. Now, let us try to know about the effective resistance in the parallel circuit. How to find the effective resistance in the parallel circuit? Let I is the total current in the circuit, V is the total voltage in the circuit, I1 is the current flowing through the resistance R1, I2 is the current flowing through resistance R2, and I3 is the current flowing through resistance R3, R is the R is the total or the effective resistance in the circuit. The total current in the circuit I is equal to I1 plus I2 plus I3. Okay. So, by Ohm's law I is equal to V by R. So, let us replace this equation and substitute this equation in this first equation. So, by Ohm's law I is equal to V by R. So, V by R is substituted in this equation. So, V by R is equal to V by R1 plus V by R2 plus V by R3, that is I1 is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. So, let us take V as the common factor. Therefore, the equation becomes V by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. So, V and V gets cancelled. Therefore, the effective resistance 1 by R, that is the reciprocal of the effective resistance, that is 1 by R, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the effective or the total resistance in the parallel circuit. Therefore, what are the characteristics of the parallel circuit? The characteristics of the parallel circuit are: the total current in the circuit is the sum of all the branch currents. Here how many branch currents are there? There are 3 branch currents. So, the total current in the circuit is equal to the sum of all the branch currents, that is I is equal to I1 plus I2 plus I3. And the voltage across each parallel branch is same. Here there are 3 branches. So, V is the voltage applied across R1, similarly V is the voltage applied across R2 and the voltage applied across R3 is also same, that is equal to V. So, the same voltage appears across each resistance in the parallel circuit, and the total or the effective resistance, that is the reciprocal of the total or effective resistance of the circuit, is equal to the sum of reciprocals of the individual resistances connected in the circuit. The effective resistance of the circuit consisting of n number of resistances, that is the equation what we have derived is for the effective resistance which consists of only 3 resistances. If there are n number of resistances, then what will be the effective resistance? In that case, it will be equal to 1 by R, that is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 up to 1 by Rn. This is the effective resistance in the parallel circuit. So, these are the characteristics of the parallel circuit. So, what is the difference between the series and parallel circuit? In the series circuit, the total current which is flowing through all the resistances is same, whereas in the parallel circuit, the voltage applied across all the resistance is same. In series circuit, there are different voltage drops across each resistance, whereas in case of parallel circuit, the currents will be different. That is, the current flowing in each resistance depends on the magnitude of the resistance. These are the differences between the characteristics of the series and the parallel circuit. Now, let us look into another type of pattern in which the resistances can be connected, and particularly the effective resistance of a circuit containing 2 resistance in parallel circuit is given by R is equal to R1 R2 by R1 plus R2. So, this circuit shows the parallel resistance connections. Here there are 3 resistances R1, R2 as well as R3, and how they are connected? They are connected in the parallel configuration, and this shows a circuit, another example for the parallel connection of the resistances which shows the source of supply, that is the battery, with 3 resistances connected in parallel. So, this connection shows the series parallel connection of resistances. How the resistances are connected? Just look into the 2 resistances. There are 3 resistances R1, R2 as well as R3. How they are connected? R1 and R3, they are connected in parallel, whereas R2 is connected in series with this parallel combination. So, this circuit is a combination of both series and parallel circuits. that is R2 is in series with the parallel combination of R1 and R3. The entire combination is connected across a supply voltage of V1 and I is the total current which is connected in the circuit, and this current when it comes to this point it splits into two currents I1 as well as I3, and as the same current I is flowing through the resistance R2. So, what will be the characteristics of series and parallel circuits? In case of series and parallel circuits, it contains the characteristics of both series as well as parallel circuits. This circuit shows the actual, that is the practical circuit, which consists of three resistances which are connected in the series parallel configuration. You just look into these two resistances. These two resistances are connected in parallel, whereas that parallel configuration is connected in series with another resistance. So, this is the example for series parallel connection of resistances. So, with this information, let us try to solve some of the problems based on Ohm's law as well as series and parallel connection of resistances. So, let me summarize the characteristics of series connection. In series connection, the effective resistance will be equal to the algebraic sum of all the resistances, and same current passes through all the resistances, whereas in parallel connection the voltage applied is same, whereas the reciprocal of the effective resistance is equal to the sum of reciprocal of all the resistances in parallel connection. And Ohm's law, I is equal to V by R and R is equal to V by I and V is equal to I into R. With this equation, let us try to solve some of the problems on Ohm's law as well as the connections of resistances in different configurations. Let us look into this example, that is, find the resistance of a resistor which takes 15 amperes when connected to a 150 volts supply. So, in this case the two parameters are given, that is the current as well as the supply voltage. So, with this information what we have to do? We have to find the resistance of a resistor which takes current of 15 amperes with the applied voltage of 150 volts. How to find the resistance? Let us look into the data given in the problem. The data given are V is equal to 150 volts and I is equal to 15 amps, and the value of resistance has to be calculated. Resistance has to be calculated. So, what is the equation for resistance? By Ohm's law, I is equal to V into R, or R is equal to V divided by I. So, we know the values of V as well as I. V is equal to 150 volts and I is equal to 15 amperes. So, substitute these values in the given equation, that is R is equal to V divided by I. So, the value of resistance will be equal to 10 ohms. So, by using Ohm's law, it is possible to find out the resistance in the circuit if two other parameters, that is the voltage as well as the current, are known in the circuit. Now, let us try to solve another problem based on Ohm's law. So, the problem is a resistance of 200 ohms is connected across a supply of 250 volts. Find the current in the circuit. Okay. So, in this case the resistance value is given and the supply voltage is also given, and we have to find the current in the circuit. Once again, the current in the circuit can be found by using Ohm's law. So, let us look into the data given in the circuit problem. The data given is R is equal to 200 ohms and V is equal to 250 volts. So, by Ohm's law, I is equal to V divided by R. I is equal to, substitute the values of V and R. I is equal to 250 divided by 200, then you will get the current value I is equal to 1.25 amps. So, this is how to find another parameter if R and V are known. If R and V are known, then by using Ohm's law, it is possible to find the current in the circuit, and try to understand this fact, that is the unit of current is amps, unit of resistance is ohms, as well as the unit of voltage, it is equal to volts. And let us look into another problem. If 15 amperes is to be circulated through a circuit of 150 ohms resistance, what voltage is to be applied to the circuit? Okay. In this case, what are the values are given? The given values are the current which is flowing in the circuit and the resistance which is there in the circuit. The current flowing in the circuit is 115 amperes, not 150, and the resistance in the circuit is 150 ohms. So, by using these two values, we should calculate, we are supposed to calculate the voltage to be applied in the circuit. So, once again list out the data which are given in the problem. The data given is I is equal to 15 amperes, R is equal to 150 ohms. So, once again by using Ohm's law, this is another mathematical expression, that is V is equal to I into R. Okay. Keep this point in mind, that is Ohm's law can be expressed by using 3 different mathematical expressions. This is one form of Ohm's law, that is a mathematical expression. V is equal to I into R. So, the values of I and R are known, they are given in the problem. So, V is equal, substitute those values of current as well as the resistance. So, V is equal to 15 into 150 ohms. So, the value of V will be equal to 2250 volts. So, this is how we can calculate the values of current, resistance as well as voltage by using Ohm's law. By using the same method, we can calculate any of the parameters in the given problem. Now, let us look into the effective resistance in the circuit, and also by using the Ohm's law, we can calculate the total current as well as the voltage applied across the different resistances which are connected in different configurations. So, let us look into those problems. So, this is another example for the Ohm's law. So, the problem is an oven takes a current of 16 amperes at 220 volts. It is desired to reduce the current to 12 amperes. Find the resistance which must be connected in series and voltage across the series resistance. In this circuit, this is somewhat different from the previous problems. Okay. In this case, what is the given problem? That is, there is a oven and it takes a current of 16 amperes and the supply voltage is 220 volts. And if it is desired to reduce the current to 12 amperes, how to reduce the current to 12 amperes? Because the current, the initial current is equal to 16 amperes and the current has to be reduced to 12 amperes. The current can be reduced by connecting resistance in series with the circuit, because the resistances are used in the circuit in order to limit the current. So, to limit the current, another resistance has to be connected in series. It is given in the problem, that is, find the resistance which must be connected in series. So, what value of resistance has to be connected in with the oven to reduce the current to 12 amperes, because initially the current flowing in the circuit, it is equal to 16 amperes and it is desirable to reduce the current to 12 amperes. So, to reduce the current to 12 amperes, another resistance has to be connected in series with the oven. So, what would be the value of resistance which has to be connected in series, and what would be the voltage across the series resistance? How to find the value of the resistance? Let us try to solve the problem. So, what are the data given? The data given are the supply voltage is given, that is B is equal to 220 volts, and the initial current, that is I1, let that current be I1 and that is equal to 16 amperes, and the desired current, the reduced current, let it be I2 and that is equal to 12 amperes. Okay. So, with this information, let us try to find out another resistance, that is R2. Let us call that as R2. So, first before that one, let us try to find out what will be the initial resistance in the circuit. So, let that initial resistance be R1. So, by Ohm's law, R1 is equal to V divided by I1. So, what is the value of V? It is equal to 220 volts divided by I1, that is equal to 16 amps, and the value, the resultant value will be equal to 13.75 ohms. So, R1 is equal to 13.75 ohms. This is the resistance of the oven. Okay. So, with this resistance, the current flowing is 16 amperes. Okay. Now, we want to reduce the current to 12 amperes. So, another resistance has to be connected in series with the O1. So, let another resistance be R2. This resistance R2 are to be the resistance that is connected in series with the O1 to reduce the current to 12 amperes, that is I2 into R1 plus R2, that is equal to V now, because these two resistances are connected in series. Therefore, let us try to find out the value of R2, and with this equation R2 value will be equal to V divided by I2 minus R1. Okay. So, R2 is the series resistance which has to be connected with the initial resistance. So, R2 value will be equal to 220 divided by I, that is I2. I2 is equal to 12 amperes. Therefore, it is 220 divided by 12 minus the resistance, that is 13.75, the initial resistance. Now, it will give you the value of resistance equal to 4.58 ohms. So, the total voltage across the resistor R2, it is given by V2. So, what is the value of V2? By Ohm's law, V is equal to I into R. So, V2 will be the voltage drop across the resistance R2. So, V2 will be equal to current flowing through the resistance multiplied by the magnitude of resistance. Therefore, V2 is equal to I2 into R2. Therefore, it is equal to 12 into, what is the value of resistance R2? It is equal to 4.58 ohms. So, V2 will be equal to 54.96 volts. In this way, we can limit the current in the circuit to 12 volts by introducing another resistance of 4.58 ohms in series with the O1. So, with the introduction of this resistance, this current in the circuit has been reduced to 12 amperes from the initial value of 60 amperes. So, this example shows that resistance is a current limiting device. Resistor is a current limiting device. So, by using such resistances in series with the existence value, it is possible to reduce the total current in the circuit. Now, let us look into another problem. This is to find out the effective resistance in the circuit. So, this problem is about the series connection of the resistances. The problem is two resistances of 20 ohms and 30 ohms are connected in series across a 100 volts supply. Find the effective resistance and total current in the circuit. Okay. So, how many resistances are there? Two resistances. The two values, let it be R1 and R2. One is 20 ohms and another one is 30 ohms. This configuration is series configuration. The entire series circuit is connected across a supply voltage of 100 volts. So, in such a circuit, what would be the value of current and resistance? Let us try to find out. You know that in a series circuit, the effective resistance is given by the effective resistance is given by R is equal to R1 plus R2, or R is equal to R1 is equal to 20 ohms and R2 is equal to 30 ohms, and the algebraic sum of this is equal to 50 ohms. Okay, 20 plus 30, that is equal to 50 ohms. So, the total current I is given by Ohm's law, that is I is equal to V divided by R. Therefore, value of V is equal to 100 volts and the effective resistance is equal to 50 ohms. So, I is equal to 100 divided by 50, I is equal to 2 amperes. In this way, we can find out the effective resistance as well as total current in the circuit. This is an example for parallel configuration of resistances. The problem is three resistances of 10 ohms, 20 ohms and 30 ohms are connected in parallel between the points A and B. Find the effective resistance in the circuit if voltage of 120 volts is applied between A and B. Also find the effective current in the circuit. So, what are the values given? So, observe the data given. The data given is R1 is equal to 10 ohms, R2 is equal to 20 ohms and R3 is equal to 30 ohms. V is equal to 120 volts. So, we have to find out the values of I and R. How the three resistances are connected? The three resistances are connected in the parallel configuration. So, what would be the effective resistance in the circuit? The effective resistance in the circuit is given by the equation 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Substitute the values of R1, R2 and R3 in the given equation. By substituting the values, we get the equation as 1 by 10 plus 1 by 20 plus 1 by 30. So, the effective resistance, that is 1 by R, it is equal to 0.1833 ohms, but it is not R, it is 1 by R, that is the reciprocal of the resistance, that is 1 by R. So, get the value of resistance, therefore, that will be equal to 5.45, that is 1 divided by 0.1833, you will get the value of 5.45 ohms. So, that will be the effective resistance in the circuit. The effective resistance in the circuit we have calculated. Next is to find out the effective current in the circuit. What will be the total current in the circuit? The total current in the circuit, let it be I. So, by Ohm's law, I is equal to V divided by R, that is equal to V is equal to 120 volts divided by the effective resistance is 5.45 ohms, then you will get 22.02 amperes. Therefore, in the parallel circuit, the effective resistance is given by the equation shown in the problem, and the total current can also be found out by using Ohm's law. So, this is an example for parallel configuration of resistances. Okay, this is how to find out the effective resistance in the parallel configuration. So, this is the combination of series and parallel circuits. So, let us look into the problem. A resistance of 5 ohms is connected in series with the parallel combination of 2 ohms and 10 ohms. The total combination is connected across the 200 volts supply. Find the effective resistance and the total current in the circuit. So, the data given, let us look into the data given in the problem. The data given in the problem are the three resistances are given, but how they are connected. This is the series parallel configuration. Let the three resistances be R1, R2 and R3. Okay. So, R1 is the resistance which is connected in series with the parallel combination of R2 and R3. So, R1 is equal to 5 ohms, it is connected with the parallel combination of R2 is equal to 2 ohms and R3 is equal to 10 ohms. So, this configuration, this connection is connected across a supply voltage of 200 volts. What will be the value of I and R? Let us try to calculate the resistance. First, let us try to calculate the total resistance in the parallel circuit. Which are the resistances which are connected in the parallel circuit? That is 2 ohms and 10 ohms. When two resistances are connected in parallel, the parallel resistance will be given by Rp, and Rp is equal to R2 into R3 divided by R2 plus R3. R2 is equal to 2 ohms and R3 is equal to 10 ohms. Therefore, R2 into R3 is 2 into 10 divided by R2 plus R3, that is 2 plus 10, that will give you the value of 1.67 ohms, and the total resistance R, it is equal to Rs plus Rp, that is equal to Rs, that is R1. Rs is nothing but R1, that is the series resistance. Okay, instead of R1 in this equation it is abbreviated as Rs. So, R is equal to 5 plus Rp, that is a parallel resistance, that is equal to 1.67 ohms. So, the effective resistance is the sum of total resistance in the parallel circuit and the resistance in the series circuit, that is it is equal to 5 plus 1.67, that is equal to 6.67 ohms. This is the effective resistance in the series parallel connection. So, first we have to find out the effective resistance in the parallel circuit, and that effective resistance is again connected in series with another resistance. So, the total resistance will be the series combination of this resistance and the parallel connection of the other two remaining resistances. then the total current in the circuit is once again given by Ohm's law. I is equal to V by R, that is equal to V is equal to 200 volts divided by the total resistance in the circuit, that is 6.67, that is equal to 29.38 ohms. This is how to calculate the total resistance in the circuit. Okay. So, with this information you can solve number of problems which consist of resistances either in series or in parallel or the combination of all these three resistances. Okay. So, let us try to solve two more problems on this one. Now, let us take this problem. Two resistances of 30 ohms and 30 ohms, both are 30 ohms resistances. They are connected in parallel across a 100 volt supply. So, let us draw the circuit diagram. This is one resistance 30 ohms and another resistance of 30 ohms. They are connected across a supply of how they are connected? They are connected in parallel. So, if this is the circuit, so what is the configuration? This is the parallel connection of resistances. The two resistances are connected in parallel across a supply voltage. So, let us consider these two resistances as R1 and R2. R1 is equal to 30 ohms and R2 is equal to 30 ohms. We have to find out what is the total current in the circuit and the branch currents, that is the current which is flowing through resistance R1 and current which is flowing through resistance R2. So, let this be the current I1, this be the current I2 and this is the total current in the circuit. Okay. So, with this circuit let us try to find out I1 as well as I2. Okay. So, how to find out I is equal to V divided by R. Therefore, to calculate the value of I, we need the total resistance in the circuit. So, to find out the total resistance in the circuit, this is a parallel combination. Therefore, the total resistance R, it is equal to, in a parallel combination, it will be equal to R1 R2 by R1 plus R2. This is the effective resistance when two resistances are connected in parallel. So, let us substitute these values, that is equal to R1 is equal to how much? It is equal to 30 ohms, R2 is also 30 ohms divided by 30 plus 30, R1 plus R2. So, if you solve this equation, the value of resistance will be 15 ohms. Do not forget to put the unit. What is the unit of resistance? That will be equal to 15 ohms. This is the effective resistance in the parallel circuit. Okay. Now, we have calculated the resistance of R. So, substitute this value of resistance in the equation. I is equal to V by R. What is the value of V? V is equal to 100 volts. V is equal to 100 volts. Therefore, substitute in this equation by Ohm's law I is equal to V by R. So, V is equal to 100 divided by 15. So, what would be the value or the magnitude of resistance? That will be equal to 6.66 amperes. What is the unit of current? The unit of current is amperes. So, the magnitude of total current I which is flowing in the circuit, it is equal to 6.66 amperes. Okay. So, now we have found out the value of current I which is flowing in the circuit. Now, let us try to find out the branch currents, that is I1, the current which is flowing through resistance R1 and another current, branch current I2 flowing through R2. Okay. How to find I1? Okay. I1 can be found out by the same equation, that is V by R1. V by R1, So, V by R1 it is equal to 100 divided by 100 divided by R1 value is 30, that is 3.33 amps, and I2 will be equal to V by R2. The same voltage is used because both the resistances are connected across the supply voltage of 100 volts. Okay. Therefore, once again I2 will be equal to 100 divided by 30. Once again 100 divided by 30, that will give you 3.33 amps. This is the total current which is flowing through resistance R2. Okay. So, this is how to find out the two currents which are flowing in the two branches, that is current flowing in resistance R1 and current flowing in resistance R2. So, what is the value of I? I is equal to I1 plus I2, you can cross check the value, that is I1 is equal to 3.33 and I2 is also equal to 3.33 amperes. So, what will be the total value? That is equal to 6.66 ampere. Okay. So, the total current in the circuit, once again it is same as the value what we have found initially. So, this is how to find out the total resistance or the effective resistance in the circuit, that is in the resistances when they are connected in parallel. So, with this information, let me wind up the class. So, let me summarize today's concepts what I have explained. In this class, I tried to explain the effective resistance in the parallel circuit, and we also tried to solve some of the problems on different types of configurations in which the resistances are connected, that is the series connection, parallel connection, and also I gave some examples on Ohm's law, that is to find out the current, voltage as well as the resistance. I hope you have understood all the concepts. Thank you.